Hello people. The month of March has passed and now it is time for my third devlog about Zozo game. This month I decided to implement cropping feature into my game engine. This feature makes drawing functions maintain within the specified bounds. The hardest cropping implementation was for draw image scaled function, which draws an image from the sprite sheet, scaling it twice in each axis. This function takes 400 lines of code when my full audio render function takes only 500. The main complication was the fact that sometimes it must crop half of pixel from the image and still manage it properly, even if flipping is applied. Besides cropping, I also implemented external sprite sheets that can be loaded and used to draw images. I will need it for my next feature for my game engine. Drawing macros. In future, just macros. Macros are a compressed set of commands that describe how to draw some certain picture using simple shapes or parts of the sprite sheet. The reason why I do this is because of 1 MB size limitation. There are a lot of big images I will need to draw, and storing them pixel by pixel will drain a lot of space. The picture you are seeing right now takes 23,040 bytes to store as a raster image. However, it only takes 222 bytes to store it as a macro, which is 100 times less. As you can see, having this feature will save me a lot of space for more content in the game. I am planning to make a separate program that will take BMP picture, convert them into sprite sheets that my game knows how to read, and place them as a reference for tracing to make the process of creating macros faster. I'm not sure if I will be available to showcase them in my next devlog because next month I am planning on working on audio until it's completely finished. Speaking of audio, I have a solution for the sync issue. When I push the first block to the audio driver, I store a timestamp of this moment, set first loaded sample as 0 and last loaded sample to the value of the audio block length. Each time I write a new audio block, I append the audio block's length value to the last loaded sample. After that, at the beginning of each frame, I calculate audio position by creating a temporary timestamp to know the time interval that passed since I loaded the first audio block. Using this interval, I can calculate which sample is supposed to be playing at this moment. If last loaded sample is later than the current sample, that means no desync has happened and music position can be calculated right away. If this sample is later than the last loaded sample, it's obvious that desync has occurred. In this case, after writing a new block, I create a new timestamp for first loaded block and change first loaded sample value to last loaded sample. This way, when checking which sample is playing, it's going to use a new timestamp and append first loaded sample value to the result to compensate the sample loss. When writing music to the block, it stores the sample it started writing it from. To get the current sample of the music, it's enough to just subtract the first sample it started writing music from the current sample we calculated before. Then, the sample can be easily used to calculate current beat of the song. The audio still contains a lot of problems that need to be fixed. I really hope I can finish working on this audio.c file by the end of April and never open it ever again because I'm really starting to hate it due to how frustrating audio problems are. That's it for the third devlog of Zozo game. Thank you for your attention and see you later.